Okay. Number 14, manufacturing sector. Yeah, again, 17% is a distractor. How do we calculate mean? I think we're done. You can't really do mean and standard deviation unless there's some, no, there's nothing hiding here. At least on this online calculator, there's no mean and standard deviation. It's a pretty simple formula though. So for the 50 and again, it says 99%. It doesn't say anything about defects, so I guess we're calculating the mean defect-free number, the mean number of defect-free items. Well, that's P times N 49.5. Standard deviation, interestingly enough, is the same for whether it's defects or defect-free. They're just complements of one another. And what is that? That's square root of N times P times Q, or its complement. And most values will be between two standard deviations. Now we can't go two standard deviations to the left. I'm sorry, a 49.5. We can't go two standard deviations to the right. 50 is our max. But you can take that and use the 2 sigma rule or the 2 standard deviation rule and say, oh, 1.4, so we really don't expect anything below 48. And you know, let's just look at that over here. What does that look like? 50 and 99. And there's that distribution. So once you get past 48, there's just a tiny tail of probability, but we don't expect to look at a lot of 50, a batch of 50, and get 45. Only 45, only 46 defect-free parts. We expect 50. We expect perfection. Let's try 3% of eggs store. Okay, so it's maybe I'll bypass 15 and 16. It's n times p square root of npq for those two numbers. Number 17 is now something new, and it doesn't use the secret word. What is the secret word here? Let's go to the calculator. What kind of distribution are we using? We are using a geometric. How do I know that? I'm reading the question, which I do not have on the screen. What is the probability the 5th customer is the first? So the first, we're either looking for the word, how long do we have to wait until, or the word first is often a flag. So actually, before I go to the distribution, how could we do this on a calculator? 5th one. By the way, it's 19% chance someone's going to buy premium. So what's the complement of that? 81% chance that the first customer is not buying premium. And then we're asking about the probability that the first 4, so that's 81% times 81 times 81 times 81. We get that number. I guess I'll go ahead and click enter. And then the 5th one is the premium gasoline buyer. Well, that's multiplication rule in action, and it's not like you really have to learn something new for geometric distributions. There we have it. Now you could go to distributions. I use the up arrow because it's at the bottom of the list here. You type in your 19%. You say, what are we asking about? The first? Well, guess what? If you put in 1, the answer is 19%. But the probabilities get smaller and smaller. The most likely is going to be 19%. Why? Because then we're calculating 81% times your 0.19. And every time you multiply times 0.81, that probability is getting smaller. Let's let the calculator do the work. Geometric, PDF. Hey, what do you know? It's the same answer that we got doing it by hand. So now they're actually, how many Do we expect to have? Well, that's a formula. So we take 0.19 and we take the reciprocal of it. So 1 over p, and this button here on the calculator will give us a reciprocal. So that's our mean. Let's do the whole distribution in kind of a tricky way. Let's do stat. And I actually already have the answer there. But let's pretend I don't. I'm going to clear that. Clear? Can I clear that? Yes. So notice that 0 is not one of the possibilities in a geometric distribution because we're saying how many times would it take until our first customer buys premium gas? You can't say 0. The first customer is the first probability. That's the soonest we could have a premium customer come in, not 0. So we start with 1, and this would be the, well, actually, here's a problem. This actually does keep going. Can I use I have to use these arrows. But I don't have all day. I don't even know if I have 2 minutes left. So these probabilities are going to trail off, but they do go on forever, theoretically. So let's do something tricky. Up here in the L2, we're going to put the individual or the PDF for geometric probability, and it'll fill in those probabilities for us. So let's see what's going on here. We're going to put geometric PDF. So here's the trick. We don't want to give it a certain value. We're going to say, please look in L1. So that is second one over here. Yeah, you can find your X value over in L1, buddy. Just check it out yourself. And you hit enter, and boom, it fills it in all for you. That is, oh, that's why it stopped at 6, because the problem stops at 6. So you can ignore the 7, 8, 9. They're the answers to number 17. Your X values, 1, 2, 3, 4, 5, 6. And notice how the probability of that particular number of customer, is it the second, is it the third, is it the fourth? That probability is going down. As I said, the first customer is the most likely. Not guaranteed, right? 19%. And then the probability that's going to be the second is a little bit lower, a little bit lower, a little bit lower, a little bit lower. And construct a histogram off of these numbers. I could, let's see. It just so happens that I have a histogram set to do L1 and L2, so it looks a lot like this. If you trace, you can see, yep, there's our 19%, and then there's our 15.4%, and the probability is just going down rather gradually.